In this tutorial, we'll begin discussing the NURBS modeling. Go right up here to pull down menu and click on Surfaces. We'll create a NURBS primitive and just use a cylinder so you can see the inside and the outside of the cylinder. Click drag and then click again to create that cylinder. Let's go ahead and view that shaded object. Right down here, you can also access your primitives by clicking on the Surfaces tab. And click on your cylinder again. And we'll just delete that so you can see down in there. Alright. If you right click, you can access all of the different sub-objects there. Isoparm are the lines on the side. You can see as I drag that it selects the different isoparms that make up the surface. If I unselect, you can see that it's still selected. If you want to input an additional isoparm from this point, once it's selected, you can come up here and say Insert Isoparm, and it'll give you several options in here. Go and say Insert, and you can see that that then becomes another isoparm on the surface. Right click, you can select Control Verts, and you can see that those verts are much like the verts on a polygonal surface. However, they're not directly on the surface. If you right click and select Hull, you can see the cage for those, and you can select on that. It's like selecting on a row and edge loop. You can also select them horizontally, all of those in one row. Right click on there again, and there are a number of other ways to look at this object, manipulate the object. Okay. The one thing to keep in mind when working with the NURBS surfaces is that the NURBS surfaces are made of a square patch. But as you come in here and let's see, go to the attribute editor, and you can see that the spans are just 20 spans, and so like a polygonal object, you can have one polygon would be the equivalent of a span, and you can, as you subdivide this or convert this, you have the option of converting it at a lower or higher resolution. So this 20 polygons could become 40 or 10 and so on. Get a better look at how this is created by coming here to the cylinder history and bringing this end sweep back. You can then see that it's just simply a rectangular, a square patch, and the type of configuration that it's in is simply a cylinder. It's brought around and connected, as you can see. It's still just a rectangle. And that's one thing to keep in mind. NURBS surfaces are simply made up of square patches. Whenever you're working with NURBS surfaces, you will be creating square patches, rectangular patches, in order to make up that object. The ability to create those NURBS patches so that they're clean and together, the edges are together, is pretty difficult at times, especially when you're trying to create an organic object. But as we move forward creating this organic object for our lesson, this class period, you'll be able to see how we can go about creating those patches so that they align as best as possible before we convert our surfaces into polygonal surfaces and use the polygon tools to finish the surface. Now, as we're working, we will be referring to U and V as the direction of our surfaces. So U and V are something that we're used to associating with texture maps, but is also associated with the NURBS patch modeling. Alright, so moving forward, you just want to keep in mind that combining the smooth surfaces of these patches or sharp edges is a little more difficult. It requires planning, so we'll discuss planning before you actually get into patch modeling or NURBS modeling, so that you have a best result. The nice thing about using NURBS surfacing for your organic models is that it gives you a really beautiful flowing surface for the most part, something that you can't really get as well with your box modeling or polygonal modeling. So one thing that makes it a little different from polygonal modeling is that you can't come into certain sections and start adding a lot of geometry to get a refined or more intricate model. Come in here and add detail like you typically would by coming in and selecting a couple of these surfaces and extruding them and so forth. That's not how the NURBS patches are designed. So in order to do that, you need to come in here and start cutting into these areas and adding different patches to create that smaller definition. You can see that if I come in here and add an isoperm, it adds the definition into the area, but it adds it all over the model and not just in a certain area. Now, as we construct our objects, we'll be using a lot of curves. A curve is not something that is directly associated with the NURBS surface, but curves are used to create these NURBS surfaces. And you can also extract curves from these surfaces. If I go in here and insert an isoperm, then that isoperm can be selected and duplicated on the surface in order to create a curve to then work from. So you can see now that that is a curve that I can use in order to generate an additional isoperm surface. If I duplicate that, then select those, I come up here to Surfaces Loft, I can create another NURBS surface on top of that. So I can also generate the curves myself. If I go here to let's say front view, I can't really tell if I'm in the front view or not. Here I am. And I come up here to let's see, create EP curve tool. This is the curve tool that I prefer using. Come in here and lay down a curve, and I can, oops, go ahead and enter that in order to complete the curve. Now, this is one example of how you can create the, begin to create the side of your vehicle. And I'm going to duplicate that, bring it over again. I'm going to select these curves and again give it a patch. So you can see that I can very quickly begin to create the surfacing I need in order to get a surface from my model. Let's go ahead and duplicate this again. Yep. Control D on my keyboard, and if I select all of these, I can give up myself a lofted surface again, then you can see how this is beginning to respond to these curves. Now, the really one of the really powerful things about dealing with these surfaces is that I come in here and select on the curve used to create that. As long as the history is not deleted on that curve, I can continue to shape that curve the way that I want it, just by moving that curve or moving the curve components in order to get the appearance that I want. Another really powerful feature of NURBS modeling is if you want higher resolution on this curve or on this surface, you can rebuild your curves, and for that matter rebuild your surfaces in order to create that higher resolution. By that I mean because of course the patches, the NURBS surfaces are independent of resolution, but what we'll be looking for as far as surface detail is the number of spans within that surface in order to create the or convert this patch to polygons. So while we're creating these surfaces, we want to make sure to create them in a way where we're going to get square polygons as a result of this surface. So we can come in here and rebuild this surface. It's longer than it is wide, so we'll need more isoparms going the length rather than the width. So I'll come right here to Edit NURBS, Rebuild Surfaces. I'm going to bring up my Options box. Right here is where I will be inputting my specifications in order to rebuild this surface. So number of spans U, number of spans V will be indicated here. So perhaps I want 20 by 10. So it looks about as twice as long as it is wide, so we'll see what happens here. Alright, so as you can see, when that surface is rebuilt, it is now rebuilt in a way that I'm going to get a nice square polygonal surface if I convert 1 to 1. That's one span to one polygon. And another thing about NURBS is that on the areas where there is more definition, it will automatically generate more surface detail in order to maintain that higher resolution, so to speak. Alright, so that's how you rebuild your surfaces. This is something that you'll do commonly as you are preparing your surfaces. But in this case we're going to go ahead and delete this and show you how to rebuild the curves. So if I have a curve and I want more resolution in that, I'll go to Control Vert in order to show those control vertices. You can see that I have 1, 2, 3, 4, 5, 6, 7, 9 of those associated with this curve. Now if we look very closely, we can see that on one end we have what appears to be a little box and a little open box, or a U. This is indicative of where that curve starts. So that is important to know, because if you have a surface that or a curve, one curve that starts on this end and the other curve starts on this end, then you'll get really twisted looking geometry. So